students. My name is Dr. Nitin Mishra and I am instructor for this class today. Uh, so today we will be discussing about what is machine learning and basics of machine learning. In this we will also discuss what are different types of machine learning, and then we will also discuss what are different areas or applications of machine learning.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit oxfordsparks.ox.ac.uk, follow us on Twitter and find us on Facebook.
So in this slide we will discuss what is definition of machine learning. So as you can see on the slide, that machine learning is a system that can learn from example through self-improvement and without being explicitly coded by the programmer, which means you do not have to write explicit code for the machine in order to act. Machine has the capability to learn and improve itself. Breakthrough comes with the idea that machine can singularly learn from data to produce accurate results. So as you know that machine learning is a field of AI, and in AI we are focused on development of artificial intelligence. So what happens, machine learning is a phenomena, means is a system which learns from the data, and according to the behavior of data it develops code in itself. For example, if I ask any machine uh, which is using machine learning, so if I will give him data that 65% pass, 70% good, 75% good, 62% pass, then from this data it will automatically generate algorithm where it can differentiate that if any percentage is greater than 70%, it is good, and it is When it is less than 70%, it is simply coded as pass. Now over a period of time, suppose some more data comes where uh, for 68% I decide good, then machine has capability to learn from that data and do the modification. So I have already told you that machine learning system is a system which can program and reprogram itself based on the behavior of data which it receives as input for learning. So before we go to machine learning system, we must understand what is algorithm and what is algorithm based systems. Like as you can see in this slide is that here we have written the algorithm to add two numbers. Okay, so what are the steps? Take the first number, take the second number, sum it and print sum as answer. So when this type of system executes, what happens? It will ask that give me the first number. Suppose you enter 2, and then it will ask give me the second number, and suppose you enter 3, then it will do the sum, which is 2 plus 3 and 5, and then it will show you that 5 is the sum. If you run this code 100 times, 1000 times or more than that, it will exactly work in the same way. Okay, suppose if instead of number, if I input A or any alphabet, it will not do anything. It will produce system error or other kinds of error, but it will not learn that what is difference between a number and an alphabet. Okay, so non-AI systems use these kinds of algorithm to give us the desired output. So in these systems which are non-AI and which are not machine learning systems, whatever we write precisely the system does n number of times. Okay, and if anything goes wrong, they give error. They do not adapt themselves according to changing needs. So this is why nowadays machine learning, AI are very much hot topic for, because they can understand and the changing need, or they can learn from changing data and they can change themselves. So if I try to draw the flow of previous algorithm example or non-AI system, it is we write the code which is depicted in this box, and then we give input to the code which is 2 and 3, and we get, and the system gives us output. Suppose I give 1 and 2, it will give me 3. Suppose I give 10 and 10, it will give me 20. But it will never learn, or it will never change itself, or it will never change the behavior in which it takes input and gives output. So this is core of non-AI system, which is different from machine learning system, which we will be covering in coming slides. In this slide, I am going to give you example of a machine learning system, which is different from the previous example. So what happens? Machine learning system takes learning data from the environment, like this data, which is given. Okay, suppose system observes following things, that at 9 a.m. it is observing a shop through camera or any other sensor. It It finds that status of the shop is open at 9 a.m. Then at 10 a.m. it is again open. Then at 11 a.m. it is closed. Okay. And then at 12 a.m. it is closed. Here I have written C, which means closed. Okay. And O for open. Now at 1 p.m. it sees that shop is open, and then again second day it observes that at 9 a.m. it is open, 10 a.m. it is open, 11 a.m. it is closed, and 12 a.m. it is closed. Now what happens? Machine learning system takes this data and understands or tries to learn from the input, and what learning it has got, it is written on the right side, that if time is between 9 to 11 it is open, if time is between 11 to 12 it is closed, and if time is greater than 1 p.m. on a particular day it is open. So this is something which is very much different from the traditional systems, because in traditional system we have to specify. Okay, so they cannot learn from the environment. So in this slide we will try to understand the difference between both the situations. Okay, one is algorithm based system where we have to give algorithm and it takes input and gives output according to the algorithm. So algorithm based system, what it does, it takes input and code is already written, it cannot go beyond the code, okay, or make any changes to the code at any point of its life cycle, and it gives data as output. Data means it has taken input and did some processing, and whatever it has given is data. Now, in contrast to this system, what machine learning system does, we give data observed or data to the machine learning system, okay, and it generates its code based on learning from that data. And now it, and what that learning in is known as model. Okay, it is a term which is used in machine learning. Now what happens, this model is the learning which machine learner has done from data. Okay, now we give input to the model, and model again gives output which is addition to the data. Okay, so, and this data is again used for learning. So what happens, over a period of time this model improves itself with number of times this system has been exposed to environment to take decisions. So over a period of time, as written in the definition of machine learning, this system improves itself, which is not possible in the first case where we have a code, it takes input and gives data. So in this slide I am going to discuss what are different types of machine learning. So as you can see the figure in this slide, machine learning system or task can be divided into three types. One is supervised learning, other is unsupervised learning, and third one is reinforcement learning. So so supervised learning, as the name depicts, that it is supervised by human beings, means whatever data is given, some learning is already supervised by human beings. And then in unsupervised, what happens, data is given, but whatever has to be done has to be done by machine learning system itself. Now we come to reinforcement learning. Okay, now in reinforcement learning is, you can say it's not precisely, but you can say it's a combination of supervised and unsupervised, where we give some kind of feedback to the learner so that it takes proper decisions. In detail we will discuss later. So in this slide we will discuss in detail, or we will discuss definitions of supervised learning, unsupervised learning and reinforcement learning, which are the three different types of learning which we had already discussed in the previous slide. Okay, so in supervised learning, model means, which is, model is the term given to the learned data. So model are trained on historical data, means you give the data, like I have given the example of that shop opening in previous slides. Resulting model can be used to make predictions on new data. So you give a historical data which is already means learning has been helped by humans. So use that data which humans have produced. Now you learn from that data and do the prediction, and based on your prediction accuracy you learn and relearn again. So this is known as supervised learning. Now unsupervised learning is something, means suppose I have given you the data and humans have not given any input. So what happens, this unsupervised learning method tries to identify trends and patterns in the data. Okay, so on the basis of trends and patterns it learns something, like something is increasing over a period of time or something is decreasing over a period of time, and this is outlier and this belongs to the group, something like that. It learns, and this whole idea is known as unsupervised learning. Now reinforcement learning, as I have told you, model uses a feedback loop iteratively to improve its performance. Like it takes some decisions, and then it takes feedback that okay, good, you have taken the right decision. Now it takes another decision. Suppose somebody says that okay, this is the wrong decision, then it takes right decision, and based on these kind of feedback loop, it learns. This reinforcement learning is used in video games nowadays with large number of instances. In this slide, I am going to discuss what are different application areas where different types of machine learning are used. In supervised learning, we have two methods, classification and regression. In unsupervised learning, we have dimensionality reduction and clustering. These are the two primary methods which are used for unsupervised learning. And reinforcement learning, only it is not categorized, only one method is there. So let us come to supervised learning. When it comes to classification, classification means classifying into some classes. It is used in fraud detection, whether this transaction is fraud or this is genuine. Email spam detection, whether this should be considered as a genuine email and it should be put inside inbox, or it should be sent to spam. Then diagnosis of different diseases, like whether you are prone to that disease or you are not prone to that disease. Then image classification means classifying image into various categories. Then regression is risk assessment on which is done on different parameters. So whether giving loan to this company will be how much risk is involved. So low risk is there or high risk is there. And then score prediction, like CIBIL score and other scores are there. No? So that are predicted using regression. So when we come to unsupervised learning, application areas include uh, text mining, means understanding information from the text, face recognition, understanding information from face recognition, means in face recognition you can identify the person, you can identify different types of animals, you can identify even expressions of the same person, whether he is happy or whether he is sad or something like that. Then big data visualization means visualization which is done from large number of data sets. Then image recognition. When it comes to clustering, application areas are biology, it is highly used. Then in city planning, clustering is used, and targeted marketing. Okay, same kind of marketing is done on same cluster. Then reinforcement learning, it is application areas are gaming, financial sector, manufacturing, inventory management, and robot navigation. So these are some application areas where different types of machine learnings are used. In this slide, I'm going to uh, explain through this diagram what may be different applications. Okay, like in previous slide I have identified application areas. Now I am categorically writing number of applications, so exact application. So come to supervised learning. The application of regression is advertising popularity prediction, weather forecasting, market forecasting, est estimating life expectancy and population growth and prediction, means population growth prediction. And when it comes to classification, diagnosis of various diseases, how to retain customers, this is customer retention application. Then how to classify different images, image classification, identify fraud and detection. Now unsupervised learning, the application of clustering or recommender system which recommends, like in YouTube videos or in Amazon shopping, some items are recommended to customers. Targeted marketing and customer segmentation, means dividing customers into different categories. Then dimensionality reduction, big data visualization, meaningful compression, structure discovery, and feature elicitation. So these are some applications of different types of machine learning.